All right. Hi, everyone. So basically today, so we're going to try this material a number of times because like that's difficult material. So basically what we're going to be talking about, assuming the projector cooperates, is again pointers in C. So pointers meaning variables that store the address of some value. So what I'm going to do is a review, and then we're going to do some exercises, and that's going to be like that for a while. So again, in C, you need to declare a variable before you use it. So that means that the first time that you use a variable, you need to say that's a variable that stores a particular type of value. So for example, you say a is an integer, and initially it stores 42. So that's called initialization. You can have variables that are of type, for example, char. So I'll say char. Some people say char. Either is acceptable. So C is initialized to have the initial value @ sign. So in order to input a single character, it needs to be in single quotes. So char star CS means that you are creating a variable that's of type char star, and the name of the variable is S. So the type is char star. And then here it's initialized to be the address of the A in the string ABS. So the way strings are stored again is if you want to store the string high, you need to store it in the memory table in consecutive addresses. And then the last thing that you store needs to be an empty character, the null character that's written as \0. Okay. So what's happening when you're doing something? So what's happening when you're doing something like S is ABS, is you're putting ABS and then the null character somewhere in memory, and then S is the address where the A lives. So then after A, there's going to be a B, and then an S, and then a null character. So you can do something like this as well. So if I, for example, have a character C, I can say that PA, the variable of type PA, is going to store the address where the C is stored. So the C contains the @ sign, and the @ sign is stored somewhere in the memory table, which I'll rename to PC. It's going to be that address where it lives. So we'll do examples in a moment. So that's what we've done last time. So you can declare an array in C. So an array is kind of like a list, except it has a type. So you can only store integers or characters or long ints or whatever, right? So for example, here you can say, I want an array of integers, meaning a block of integers. And you initialize this array with 5, 10, 2. So an important point is that you can initialize arrays like that. You cannot use this the way you would use lists. So you cannot say something like, R is now 1, 2, 3. So because you can only use for initialization. . And then like the way you use list in Python, you can use arrays in C. So you can, for example, say, I want the first element to now be 3 instead of 5. So you would say it with R at 0 is equal to 3. So the type that I didn't mention before is long int. So we've already printed long ints. So that was the printing using %LD. So this is a type that's that has a space in it. So this also by convention has a space in it. So people say car space star, and that's a type. In the same way, long int is a type. And that's an integer that on most computers, it's going to be able to store larger integers than a regular integer. So in particular, on most computers, although that's not in the standard, on most computers, addresses are going to be stored in the same way that long ints are stored, and addresses can contain larger numbers than regular integers. All right. So functions in C work like this. So a function needs to specify the return type. You need to say what able to return, and it specifies what kind of parameters it takes. So here we're saying we're taking 2 parameters. Both are, in this case, of type int. So we write it like this. So in Python, we would just write AB. In C, we write int A, int B, so that A has a type, B has a type. And then in the same way that in Python, you would say return, you could say return A plus B. You can have, of course, other stuff in the function as well. So functions interact with pointers in an interesting way. So you can say, I want to send F a variable of type int star. So this means that F is going to take a value that happens to be an address of an integer. And then here what we're saying is take this address, go to this address and put 43 in. So if you want an analogy with Python, this would be analogous to passing a list in Python, right? So if you pass a list in Python, you can then inside the function say, go to that list and modify a value inside that list. In the same way, in C, you can say, I'm sending you an address, and the function is going to be able to go to that address and modify the value at that address. All right. So in fact, all that's ever happening in Python is you're passing addresses, right? So when you're passing integers in Python, you're also passing addresses. It's just that it happens that for an integer in Python, you cannot say, go and modify the value at that address that happens to be an integer. In C, you can. All right. So what's different about C, and we'll see that, I think I'm one, nothing, right? One. Oh, it's out of battery. All right, I'll use. All right. Yeah. So what's different about C is that you can, in fact, pass integers, and then you're just passing the value. You're not passing the address in this case. So this is something that we will get to on Thursday, probably not today. So the other thing is in C, when you're using an array, in fact, what's happening is you are converting it to a pointer anytime that you're using it. So we'll see that in examples. So A at 0, it looks like you're saying access the X is the first element of the array A. In fact, what's happening is A gets converted to the address of the first element, and then the 0 is just plus 0. So A at 0 is in fact star 0, which means go to the address A and get me the element at that address, which works out with arrays because you're getting the address of the first element. So star that is the first element. So, okay. So what I want to do now is just a few examples of running C code with this kind of stuff. And then we'll do the memory model exercises. So, okay. So this is just so that I'm able to print. So here, what I want to do is I want to print 8. So if I run this, so again, for some people, it's going to show up in the debug console. If you want to change that, you can, but it depends on the computer how exactly. But it's on ECF, and on my machine, it shows up in the terminal. So here we just printed 42. So just kind of to show you what happens when things break. If, for example, I neglect the semicolon, like you usually see, a lot of the time, the error shows up on the next line rather than on this line, because over here, see, the compiler doesn't yet know that there is a problem. It's just waiting for a semicolon, and then instead of a semicolon, eventually it gets to printf. So printf is where it says there is a problem. So generally in VS Code, if there is the red underline, that means that there's probably a problem. So if you try to run it, one thing that sometimes happens is it'll still run because what's happened is the program already exists from the time that it was actually working, but it did not get updated. So if I go, so I need to go to problems. In general, the number of problems when you run things should be 0. So here, this is the lab handout, which I'll just close. So in A.C, here, it actually figured out that, okay, like printf is a problem, and the reason is it was expecting a semicolon. So another thing that can happen is here I say AA rather than A. So in Python, this would crash when you run it. And that's because Python has no way of knowing that there is not a variable AA before it actually gets to the line, because who knows, maybe you like call a global function just before, and in that function you define the global variable AA. Who knows? In C, because you must declare things ahead of time, it can know ahead of time that AA is not declared, and therefore that's a problem. That's one of the advantages of writing in compiled languages, is that you write a program in Python, it doesn't know until it actually runs the line that there is a problem, so it will crash when the user uses it. Here, it won't get to the user because it won't let you compile, because it knows that AA was not declared. You never said what the type of AA is. So I try to run it. Again, I can look at the prompt, and here it says AA so here it says AA undeclared, and that's kind of like a hint. And then the actual error is you get to AA, and that was never defined. So again, you got to be careful about this kind of looking like it's working. It's definitely not. So like if I save it and I run it, it says 42 because it runs the previous version of the program, which actually was working. Here, it'll say that there is a problem. Again, the number of problems should be 0. So, okay, if I fix it, for example, by changing this to AA, that is now fine, although it still for some reason thinks that I'm trying to compile lab 1, which I have done this morning. So, okay, but here it says that the problem is in like lab01.tech. So the reason, by the way, it does it is because basically I saved a.c in the lab01 folder, and lab01 also contains the source code for lab1, which it also tries to redo, but it says that this is this, so not a problem. If I save, let me save this program in a fresh folder that doesn't have other garbage like lab1. It's not garbage, it's in fact a very good lab. Here we get 40. It still insists that it's trying to read lab1. I'll open the folder. That's in fact in the instructions for lab1. I'm just a little bit lazy about it. So now that I've opened the folder where a.c is contained, definitely not. Julia, no. And now that's the new one, and there are no problems. So now let me just write the function. So let's say that I want to write double sum, and here I say double x, double y, and I return x plus y. So here what I'll do is I'll say, okay, so double s is, let's say, sum short. And here I make sure that this is in fact a double and not anything else. This is a double and not anything else. And then I'll store the result in S. So, okay. So now I can print S using %f, like so. And here we are, we got 4.6. So again, you might try to break it. So you might say LD instead of %f. So this says, interpret the value that I'm sending to you as if it were a long int. And here, what it did is, it in fact did what I asked it to, which is interpret the data that I'm sending it, which is in fact a double, as if it were a long int. And the actual data in the memory table, you can interpret it as if it were a string, as if it were a double, as if it were an int. We'll do the details of how to do that later. And it just does what I asked it to. So just interpreted it as if it were a long int, and it happened to be this long int, which of course makes no sense. So the yellow underline means a warning. So here, it's not an error. It generated the program, but it warns me that I'm probably doing something that makes no sense. And here the warning is that, well, this is actually a double, but I'm writing the program as if it were intended to be interpreted as an int. A warning usually means that there is a problem. Sometimes it's the case that that's what I wanted, right? So that was the situation where I defined hello, and then I printed is stored at address %LD. And here I actually meant to display str first as if it were a string, and then as if it were a long int. And I actually wanted to do that because I wanted to know where this h is being stored. Now, that's not the usual thing that you want to do, because usually the computer decides where to store the string. You don't care. So this would, again, be a warning. But in this case, I can choose to ignore the warning because that's actually what I wanted to do. I can also get rid of the warning by explicitly casting the value. So this is kind of like converting between types, but it's in quotes because it does the same thing as printf with the wrong type. Interpret the data as if it were in the type I say. So the way you do it is, for example, something like this. So sometimes that would work, but sometimes so that's kind of that's the truncation. That's the same as in Python, but sometimes it does something that does not necessarily make sense. So it's not as if it takes, like, even if this is digits, it's not as if it will convert it to a number that represents the same quantity as the number at str. It'll just give you the address. So in this case, if I say this and then save, after a while, the warning should go away. Okay, so this is just a preview. We'll do that later on. So the warning doesn't always go away right away, but it will eventually. So here it still says expects argument of type log int, which I have given it. So I think if I run it, yeah, now it's gone away. Okay, so let's do some examples with arrays. So I'll initialize the array to 5, 6, 7. And I can print array at 0. So that would just be 5. I can print array. So this is where the array starts. So the address of and note that in Python, you would expect that you would print the array. Not the case here. What you'd print here is the location where the array starts. And you can do something like this. And this would, again, be 5. And the reason is array gets converted to the address of the first element of the array, and star array means go to that address and get me the value. So array by itself is the address of the 5. Star array is the 5 itself. So star array is the same as array at 0. In a more elaborate way, the same as star array at 0. So strings work exactly the same way. That we already have actually, but so that, by the way, will produce an error. You cannot declare something twice, but I'll declare str2 to be hello as well. I can print str2 at 0. So this is the same kind of thing as this. So I specify that str2 at 0 is a character, and it'll print the h. So that is the same as this, and the same as str2 plus 0. Make sense? Questions? Yes. Well, so plus 0 just means that it's still str2. And the 0 corresponds to the 0 here. Yes. You can, there is a subtle difference between those. Yes, you can do that. So there is a subtle difference. I'm already throwing a lot at you. So the difference between the square brackets and the star we'll do on Thursday or Friday. All right. So that's like that. And back and doing examples is using a function with so if a function doesn't return anything, we say void, because you can't say nothing. So void means the function doesn't return anything. And here we'll do something like that. So if you say change a address, so let's do it in a slightly simpler way first. So this is like this, right? So I'm saying store the address where AA lives in the variable PAA. Then I'm sending PAA over here. So the address, whatever it is, gets copied to PA. And then the instruction here is go to address PA and put 44 in it. So star PA means go to address PA and operate on the value at that address. So what I've done in the last 40 minutes is give you the rules for how the syntax operates. That's not the same as teaching you to use it, in the same way that kind of people telling you in third grade how multiplication and addition work and how roughly they're defined. That's not the same as giving you facility with algebra. That came like whenever it did, like in grade 9 or something. And I think it's important to recognize it. Like, so the rules are like not that difficult. Like there is basically, let's list out the things that they said. So int star, it stores the address of an int, and then star a means, let's make it PA, means the value at address PA, And then address of A means the address of A. And then copy the value to the local variable from the function call, same as in Python. So that's basic. And then we had the arrays, right? So array at 0 is the same as star array. So that's basically all the rules that we had. Operating on them is a different thing. So what I want to do with the rest of the time today is just do examples with operating with those rules. This is like not everything that you need to know for the ESC190 example, but in terms of like what are the rules, this is like half the rules right there. So of course, in the same way that kind of operating on arithmetic and operating on variables in algebra is a different thing than just knowing the rules. It's the same in C, so that comes with practice. The problem that we're facing here is, in addition to needing to operate on the rules, you also need to write code that compiles and do that together with understanding the rules. So it's going to feel a little bit overwhelming in the first couple of weeks, for some people more than a couple of weeks, but I don't think there is a way around that. There's a question. Yes. Yeah, you will see that in the examples. Okay, so let's go to the exercises. Yes, I'll answer this like that. That's gonna come up a lot, so I'm not gonna answer this directly, but it's gonna hopefully become clear. So let's do some exercises. Unlike with Python, C just has the memory table, right? So there's no separate variable table. It's just the memory table. And then when you say int A equals 5, what happens is C decides, okay, A is going to live at a particular address. That address is not going to change, right? So it might be that C decides that this is int A. Unlike in Python, where you can say A is now something new, and then in the variable table, A is now going to refer to a different address. In C, that's just not a thing. So once the variable A lives somewhere for that particular function, that's where it lives. Saying A equals 5 means go to this address where we decided that A lives and put 5 in there. So in a way, that's simpler than Python, right? So in Python, this would be place 5 somewhere in memory if it's not already in memory, and then copy that address copy that address to the memory table. That's not what's to the variable table, sorry. So that's not what's happening in C. So in C, you just decide A lives at 1032. That's where it lives. Similarly, maybe PA lives over here. And then when you're saying PA is address of A is 1032. So we just store 1032 in PA. So when you say printf %d A, so A gets substituted into %d, that means that the first thing that gets printed is 5. So here we're substituting PA into here. So PA interpreted as a long decimal. PA has the value 1032. So print the value of A, and then PA stores address of A. So print where A is stored. It's stored at address 1032. Star PA means go to whatever is the address that's stored here. In this case, go to 1032 and print that. There is no commas, it's just spaces. So that would be 5. Okay, so what we've done when we printed star PA is basically we said, well, get me the address of A and then go to that address and print the value there. That's the same as printing the value of A. Yes. You could have that. We will do that later. So you could say address of PA. Yes. Yes.
So the address 5 is going to be for the rest of the program.
Well, it's so the way to put it is 5 will live at that address for the duration of the function. And it's not that 5 lives there, it's that A lives there, and we put 5 in A. Well, a pointer is a variable that stores an address. It's just it's kind of a variable. All right. So this is this. All right. So here we're defining A as an array of integers. So here it's going to be slightly complicated because there is considerations about where like the 6 goes when you store the 5. And the answer in this case is it's going to get stored at intervals of 32. That's why when we did the memory tables in Python, that's what I had done. So the way it's going to go is I'm going to do it like in a little bit of a fake way, and I'll do it in gaps of 2. So this is going to be 5, and this is going to be 6, and this is going to be 7. And we're going to say that A begins here. All right. So when we are saying A at 0 is equal to 6, that means that we go to where the first element of the array is, and we change it to 6. So we also have P again. So int star P means a variable of type int star. And whenever you use an array, it just gets converted to the address of the first element. So that's going to be 1032. And now we're printing A at 0. A at 0 as a decimal is just 5. Star P is also 5. So it's basically the same kind of thing as here, where A and star PA are the same. P is the address of the first element of A, which is 1032. Star P is whatever is at 1032, which is 6. Yes.
Why is 0 not 6?
Oh, it is. I just forgot I changed it. Sorry. So, thank you. Good question. Thank you. Okay, make sense now? All right. So that's like that. So this is a function call. So here again, so 567 will store it starting at 1032. So we're again saying A at 0 is 6, and now we'll remember that we actually changed it. So A at 0 becomes 6. So A is 667 now. And now we're saying int star P is A. So let's say that P lives at 2064. and equals A means that it's 1032. And now we're going f of A. So what happens is we have the parameter in star AA to which we copy A. So if this is in star AA, what happens is we take A, and in the same way that we copied the contents of A into P, we copy the contents of A into AA. So int AA is 1032. And now we're going inside the function f, AA at 0, meaning the same as star AA, meaning go to address 1032 and change it. We change it to 7. So that means that the array A is now 767. So the shorthand here is it works the same as Python. It looks the same as Python, right? So if you pass an array to a function and then you modify an element of the array, that has an effect outside the function as well. The mechanism is kind of different. The mechanism is we're just copying A in the same way that we copied this A into the P. We copy this A into AA. And then, well, like when you say AA inside of F, that's the same as saying A in main, because we just copied A into AA, the address, not the entire contents. Yes?
But the same thing we're more explicit about modifying.
Say again?
Like, it's the same thing as in Python, but we're more explicit about the fact that we're changing things.
Well, I mean, I would say you're equally explicit in the sense that you know exactly what's going on either way. It's that when you're doing it in C, what we'll see later on when we'll see examples where it's not being modified is you're always just copying whatever is here to over here. It's just that sometimes what you're doing is you're copying an address. And when you're then going to the address, well, you're modifying the value at that address. In Python, you're always copying the address. It's just that in Python, for integers, for example, there is no way to go to that address and modify the value. In C, there always is. Yes. Yeah, so same. In fact, that's the next example. Or actually, well, it could be the next example if we made it. So I thought like maybe that's example. Wait, did I? Oh, I guess I didn't make an example like that. We might as well change the example around to be that. So me do this. So that's like that. So if this is B, then A is going to be like this, and we're sending the address of B. So int star A becomes 1032. And then inside of F, what you're saying is go to either star A or A at 0, that's the same, and put 7 in there. So that would change it to 7. So when you're printing the B here, it would print 7. I think that was your question. All right. I will see you either on Thursday or in the lab now for half of you. See ya. Bye. Thank you.